again, we don't have a lot of stuff that we're going to do all as a group, so I would really, really ask that your focus while we're here together is right up here, okay? Somebody asked me yesterday if the warm-up problems, like stuff like the warm-up problems are going to be on a quiz or a test. What's the answer to that, friends? Yes. For sure. We spend a lot of time, like I would say about a third of our class time, doing warm-up problems. So if you don't think that those are important, then you're probably a little bit mistaken, okay? You need to make sure you're paying attention. This is where we're learning the nitty-gritty of physics. You need to follow along. Now, there are two questions here. I'm actually going to start with the second one, okay? I don't know why. Well, I do know why, but just for kicks. The question says, can an object have a zero acceleration while having a non-zero velocity at the same time? Can an object have a zero acceleration and a non-zero velocity at the same time? I want to do a quick vote, so help me out. Raise your hand if you think, yes, that is possible. We can do that. Anybody say, no, I don't think that's something we can do. Okay, so I'm seeing a lot of yes. So it says yes, but then it also says give examples. So help me out. You had lots of people said yes. Tell me an example. When might this happen? Yeah, go for it.
Like when you're driving on like the highway, you're going like 70, and you just stay at 70.
Yeah, that's a simple example. It's fantastic. Exactly. So you're on the highway, you're driving 70, you're driving in a straight line. There is no change in your velocity, right? You've hit cruise, you're going at a constant speed, so you've got a non-zero velocity. But because, remember we said acceleration, hey, it's going to work, is change in velocity over time. If there's no change in that velocity, then we're good. Everybody happy here? Okay. Quincy, look at you have a question maybe. No, you're good? Okay, I just want to make sure. All right, so that was the second one. Let's take a look at this first one now. The first one says, can an object have a zero velocity and a non-zero acceleration at the same time? So let's take a vote on this one, okay? So process that if you need to. If you weren't sure before what the questions were asking and now you get it a little bit more. Can an object have a zero velocity while having a non-zero acceleration at the same time? So votes here. Yes, that's possible. We can do it. Give me a vote for no, it is not possible. Okay, and I'm seeing a few people with not hands up in the air, and I'm not going to call you out because sometimes you just don't know. Sometimes you're like, I don't know what the question means. Quincy, you had your hand up for the yes. You're the only one. Can you give, so the rule is in science, right, friends? The rule is that if you can give an example, then you're showing that it's true. Or if you make a claim and you can give a counterexample, then you're proving it's false, right? So can you give an example of a time where an object has a zero velocity and a non-zero acceleration?
So I'm thinking like when you're driving, you're slowing down, like it's only for a second. Like you accelerate into zero, you go down.
Yeah.
So you're accelerating, you're at zero.
Do you guys understand what he just said? No. I'm gonna say it just a little bit louder, but that was a great example. So how many of you have been in a car, bus, or some sort of motorized vehicle? Yeah, we've all done that, right? Okay. So you're driving at some speed, let's say 70 because we're on the interstate, and then we're gonna come and we're gonna slow down. So as we're slowing down, we're changing our velocity, right? Slowing down, slowing down, slowing down, slowing down, and the more you slow down, the closer you get to what?
Zero.
Zero. A zero velocity, right? And so at that moment, when you got into zero, you're still changing velocity. And indeed, you've got a non-zero acceleration and a zero velocity. It's awesome. Now, some people aren't convinced by that. I'm just looking around the space. Like, I'm with you, 100%, and I totally agree. Some people are like, but are you really accelerating there? So I'm going to do one more example of this. Same kind of deal, okay? So I want you to think about, I'm trying to decide how I want to do this. So there was an example that one of the other classes brought up that I thought was really kind of interesting. Imagine that you're in your car and you're parked on a hill, a pretty steep hill, okay? Now, does anybody here drive manual? A stick shift, anybody? Like, yeah, you're like, yeah, I do. Okay. Good for you. That is a skill that I would encourage you all to learn. I don't know how to drive, like I've learned like twice. It's a skill, right? Like you have to practice that a lot. So you put the car in neutral on a hill like this. You take the parking brake off. Where's the car going to go? it's gonna go down the hill. Now, if you've driven an automatic, you know also that if you take your foot off of the brake while you're sitting on a hill like this, your car is gonna do what as well? It's gonna go down just a little bit, maybe not quite as severely as a car that's a manual transmission, right? So anyway, either way, let's say that I'm parked on a hill that's a pretty steep hill, okay? I'm parked, I have my parking brake on. I take my parking brake off, take my foot off of the brake. I'm gonna start going this way, but I wanna go up the hill. So I'm gonna put my foot on the, what? I'm gonna put my foot on the gas. So I'm going down the hill. I'm gonna put my foot on the gas so that I can go up, right? But for a moment there, you're still gonna be rolling, even when your foot's on the gas. Are you with me here? You're gonna roll down the hill just a little tiny bit. And then you're gonna go back up in the direction you wanna go. So putting your foot on the gas is causing a non-zero acceleration. Do we agree? It's changing your speed. So for a moment there, you are going backwards, and then you start to go forwards. Okay? So for a moment, we're going backwards, and then we go forwards. Now, a quick question for you. If I'm moving backwards, what does that mean about my velocity? It's a negative velocity, isn't it? And if I'm moving forwards, what does that mean about my velocity? Positive? Are we okay there? If I've got a negative value and then it turns to a positive value, by definition, what does it have to go through?
Zero.
Has to go through zero. Does that make sense? Because we're moving in a continuous change from a negative velocity. So I was going to graph this and then I got distracted. So this
But it goes through zero in an instant.
It does. That's true. So I've got a negative velocity and I'm slowing down. Just for an instant, as Dimitri just said, just for an instant, it's zero and then it just keeps going. But at that instant, right? Same as what you were just saying. At that instant, for that moment, the velocity has a value of zero. Okay? And at that instant, is the car or the whatever, is it accelerating? It is. How do you know it's accelerating? Looking at the graph, how do you know it's accelerating? There's a slope, right? The slope is not zero, so it's accelerating. It's got a velocity of zero, so that does qualify it for this problem. Does that make sense?
Even if it's just an instant.
Even if it's just an instant, because for an instant, right? I mean, you could make an argument, right? You get pulled over, you're driving your car maybe a little bit more than 70 on the interstate, right? And maybe, I don't know, you hit something a little bit higher than that, and then you slow back down, right? Because there's a police officer that's coming to you, right? And the police officer says, do you know how fast you were going? Well, just for an instant, I was going 85, right? Just for an instant. But does that instant matter? It kind of does, like in the eyes of the law, like it kind of does matter, right? Just for an instant, just for a second, just for like a little, like not even a whole second, right? Just like a fraction of a second, but yes, you were going whatever speed. And that speed could be zero, okay? I'm not recommending that, and make that clear. Follow the speed limit, it's there for a reason. Okay. Sometimes people get crabby about this problem. Come back to me, my friends. We don't need to hear about your speeding stories right now, okay?
Oops.
Sometimes people get crabby about this question because they say, but you're not staying at zero velocity very long. Question for you. If I'm staying at any velocity for any amount of time, am I accelerating during that time? If I'm traveling at 4 meters per second for a long time, am I accelerating during that time? I'm not, because I'm not changing velocity. So by definition, if there's a non-zero acceleration, it means for an instant. Because while I'm only at zero for an instant, I'm only at zero, or I'm only at any velocity. Come on, for an instant. I'm only at this velocity for an instant, and only at this velocity for an instant, right? Any of those velocities, I'm only there for an instant. Yeah. It's called instantaneous velocity. What? I know, it's amazing, right? How are we doing? You okay? Yeah.
So that velocity looks like it's constant on the graph, so wouldn't that just mean it's zero acceleration?
Look carefully at what kind of a graph it is.
This one.
This is a velocity graph.
Yeah.
So the velocity isn't constant.
Yeah, so like acceleration is 0, right?
Nope. So this is a velocity graph. So okay. I'm gonna draw that question out and ask it to everybody. Is that okay? Friends, here's the question posed to you. If this is my velocity versus time graph, what is my acceleration versus time graph gonna look like? Bless you.
Oh, curve. Yeah.
The acceleration versus time. How do I get from velocity to acceleration? Slope. Tell me about the slope here. Positive and constant? Yeah? So that means the acceleration values are going to be positive and constant? Anybody know what the position versus time graph is going to look like? Oh, that's hard. But I bet we can do it because we're smart kids.
Is it gonna be curved?
I'll move that like that. Is that okay? Little technology fun there. So, excuse me, position versus time. So we got to think back. I hear people saying curve, but there are lots of curves. There's an infinite number of ways that you can draw a curvy line, even a curvy function.
Curved upward.
So let's take a look. Let's be smart about this. The values here, this is like, if you get this, you're golden on that standard. So watch carefully. The velocity here is positive or negative? Negative. And it's getting closer and closer to 0. You with me there? Which means that the slopes here need to be what? Negative and getting closer and closer to 0. Is that okay? So negative slope, and it doesn't matter where we start it. Let's start it here. Negative slope, getting closer and closer and closer to 0. So I'm trying to line this up pretty well, but I did not. There we go, kind of. And then what happens to this, or what happens to the velocity here, friends? It becomes positive and gets more and more and more positive. So what's going to happen to the slopes here? Positive and get more and more and more positive. Right? Does that kind of make sense? That's how we build these graphs. That's exactly what happens. Okay? We did this problem yesterday. Do you remember we did this? We said, where did it go? It was here. Same kind of thing, right here? Yeah? What was the displacement? 0? What's the displacement in my picture here? I'm going backwards, stopping, coming back to where I started. All the same stuff. Okay? Hopefully, in the last 2 minutes, things kind of came together for you. If they didn't, let's process this a little bit more. I want you to understand this. This is it right here. Right? I showed you yesterday the standards that we're going to assess. Right? That is it. If you understood what we just did and you are able to recreate that, explain that using words or graphs or whatever, that's what I'm looking for this standard up here. That's it. Bam. Okay? We looked at this yesterday, but I'm just going to talk about it real quick since we're here. Position, distance, displacement, speed, velocity, acceleration. You need to know what all those words mean, and you need to be able to use them. I was about to say intelligently. That sounds judgy. But you need to be able to use them appropriately. I feel like that's a nicer way to say that. And hey, then there's these acceleration problems. Speaking of which, let's talk for a moment about today's plan. Okay? Yesterday, I told you that we were going to have a quiz tomorrow. Yesterday, that was Wednesday. I told you we're going to have a quiz tomorrow. That's Friday. Okay? Thinking about that, looking at that kind of in the realm of your life and your world, that doesn't make sense. It's homecoming week. You guys are busy, and I totally understand that. And this is totally selfish for me. I don't want to grade quizzes that are yucky. Okay? I also want you to have an opportunity to show me what you know, right? That's the whole goal of this. Like, timing-wise, I just want you to get this stuff. So, I don't feel like tomorrow's probably the best time to assess. I hope that you feel that way as well. I know, right? I know. I also feel like, again, kind of in that same vein, the weekend may be very busy for you. And if it's not, that's awesome. And you can absolutely do physics this weekend. In fact, regardless of your other plans and regardless of when the quiz is or whatever you want to call it, the assessment is, do some physics this weekend. Find some time to do some physics, okay? But I feel like, given that Friday is Friday, and then the weekend's going to be pretty busy, If we take a quiz on Monday, that's not going to give you an opportunity to ask me questions if they come up. So I've made an executive decision that we're going to wait and quiz on Tuesday. Okay? But here is the big caveat, the big thing you need to be aware of. Okay, because I want to make sure this makes sense to you.
Oh, no, there's a caveat.
There always is. Today is the last day that I am devoting in class to this material. Okay? So today is the day when you're going to do some self-paced learning. Today is the day when you can ask me questions. You can absolutely work with each other, and that's what I want you to do. Tomorrow we're going to start a lab, and we're going to do that lab on Friday and Monday. So if there's like a little question that you have, I can absolutely answer that. But in general, this is the day for you to get this stuff figured out. Okay? And I need to tell you one other thing. Because yesterday when I introduced this whole concept to you, I don't think that I was assertive enough about what you need to know. So the first thing that you're doing is that blue page that had those 6 problems on it. And if you need help with 4, 5, and 6, there are videos on Canvas. If you don't, that's fine. Like, you can do that. Now, I need everybody's eyes up here. I need your mouth shut. I need your attention right here. Okay? There's a video called Introduction to Acceleration Equations. Kinematics equations is what it says. I'll fix that in a minute. It says kinematics equations. I'll fix it right now. Bam. This video is like 2 minutes long. Everyone needs to watch it. Okay? I don't care if this is all making perfect sense to you. This is information that everyone needs. If you don't watch this video, even if you are like a rock star physicist, there are things that you will probably get wrong as a result of not watching. It's, again, 2 minutes of your life will make everything make more sense. Okay? I would also strongly recommend watching the how to choose the right acceleration equation video. Okay? These are both like 2 minutes long. They will really, really help you as you start the problem solving. So if you haven't watched these yet, definitely do it. Then you have an opportunity to work on 4 problems that are in your book. The answers are here. And for each of these 4 problems, I have a video that shows how to do it. I solve it both graphically and with algebra. To be clear, bless you, on Tuesday when you take a quiz, there's going to be there'll be a couple problems like this. Okay? You can solve them graphically or using algebra. I don't care as long as you're doing good physics. Okay? Whichever way works for you. You don't have to prove anything to me except that you know how to do physics. There are some homework questions. The answers to these are on Canvas. I'll show you where they are. Okay? They are, oops, hold on just a second. Let me find them for you. So they are, let me show you, friends. They are right here. If you go into the calendar for this unit and scroll down to any set of homework, if you click on it, it will open up a Google Doc that has the answers. Okay, so they're all there for you. Okay, if you get done with all of that, you're feeling awesome. There is also a challenge problem that you are very much encouraged to work on. It's just more stuff. Okay, so it's right here, the kinematics challenge problem. Oh, it jumped. Okay, this is up to you. You need to take responsibility for your learning. Okay, we have about 20 minutes for you to work. Okay, I'm going to give you about 4 minutes to get settled, and then it needs to be fairly quiet. There are headphones over there if you need to borrow them. Do what you need to do. And I am going to call some people over just to chat for a second, but other than that, you get to work.